In terms of the way that the industry continues to reinvent itself, and of course the new topic this year is around AI, and I'm going to get to that and cover a lot of AI and the dynamics in the market as I go. We start from the standpoint of traditional supercomputing, and I have a lot of images here that I cribbed off of the website from Barcelona Supercomputer Center because I was just there recently for an event hosted by Lenovo. That's one of their major customers. And you can see a lot of the traditional areas that we see HPC in. Of course, there's been a lot of expansion of HPC into commercial markets, and that's not new. That's been going on for a long time, going back to 20 years ago when I was in product management at SGI, and we were carrying HPC into manufacturing and finance and other areas. Some of my favorite examples of this, Sydney was right, I am going to walk. For those who haven't seen these examples, the top left, Simpson Strong-Tie, is a company that's semi-local here in Pleasanton that we've talked to. They're in the manufacturing space. You can see their products in Home Depot if you like to build stuff. They make fasteners and joists, the steel bits that join the wood bits together. They started doing HPC in the time that I've been an analyst in this space, and they hired expertise from the auto industry to try to break into this market. Out of all of the HPC sites I have visited, and there are many, this is still the only one I can think of where the primary material they are modeling is wood. And stop and think about it for a second, because that's not an easy model, right? It's organic, there's all different kinds of wood. It gets wet, it warps. That's a hard model that they had to start from. The second most common material they have to model is cement, which is also not that easy. But the payoff they get when they run these models is it shortens the time it takes. That's the initial payoff. It shortens the time it takes to run that testing. Because otherwise they set up their whole experiment, they pour the cement, they say, great, let's meet back here in 6 weeks after the cement cures, then we can do our stress test. And it also makes them more responsive to contractors in the field. Hey, can I drill a hole in this to run a conduit through it? Will it still be sound? Now they can load up their structural analysis software and give an answer on the fly. This is one that everyone's familiar with, this little box of candies here that was so popular over the past year. This is one of the last conversations I had professionally with Tom Lang from P&G when he retired. I asked him, I don't know why I never asked him this before, but it was the first time I asked him, was there ever any product P&G had that they wanted to come out with for a long time, but until they modeled it, they couldn't get it. And he had one like that, and it was this. The Tide Pods. He said it wasn't like we didn't think of this, right? He said we've been wanting to come out with this product for 75 years. Now, their competitors had done laundry detergent tablets that were the compressed powders, but those were never very successful because they do poorly in cold water. You get grit in your clothes. So they knew they wanted to come out with a liquid. Now, they have liquid detergent. They have liquid fabric softener. The hard thing to design in this product is the envelope. And I'd never really thought about it till he talked about it, but the envelope you have, that plastic, you need something that dissolves immediately and completely in cold water, but doesn't get dissolved by the liquid inside the envelope, right? And it has to be shelf stable for a long time at a range of temperatures and humidities. So, all right, that's already pretty hard. Now, you have to get the liquid inside the envelope on a manufacturing line at about 30 miles an hour. And if you think you've got all that, if this costs more than about 25 cents a pod, forget it. It's not a goer. People aren't going to buy them. So this just kind of gives me a great feel for the engineering that goes into everyday products that we have in the industry. These aren't huge supercomputing sites. This is my other favorite when I talk to sorry, no company name on this one. I'm not authorized to use it, but I talked to the CEO of a company that does aftermarket wiper blades. And they consider themselves to be a high-quality aftermarket wiper blade, okay? And I was talking to this CEO, and I asked him, do you ever do any HPC, like simulations or aerodynamics or anything like that? And he said, funny you should ask, it just came up. The new The lead designer on their new product had just come to him and said he was worried that they were going to have trouble on the new design with wind lift, which was, again, a term I had never heard until that moment, but I kind of got it, right? Your windshield wipers are doing this, and the car's moving, and if it flips up off the windshield, that can't be good, right? So it needs to stay down. So I said, well, all right, what are they going to do? He had said, well, we have three options. One is we could supposedly do a wind tunnel test. I don't have a wind tunnel. NASA's not going to let me borrow their wind tunnel, so it doesn't take very long to cross that out and say it's not an effective option. Two is we could try to do a computer simulation, but that's not a really easy computer simulation. We're HPC people. You can get an idea of, by the time you've got the moving car and the curved windshield and the wind and the rain and the ice and the snow, that's a plausible but not easy CFD simulation. And the third thing we can do is mock up the windshield wiper, put them on a rental car, and go out on the highway with a clipboard and see what happens, right? Which is what they'd always done. And now I can't make it rain or snow, but I can, look at where it's going to snow and mail them to my partner, and he'll do it, right? All right, so what do you do? So he said, well, we're going to do the CFD simulation. And that impressed me. I said, why? He said, well, because my engineer told me that in the long run, it's our best bet at maintaining a quality lead over our competition. It makes us more responsive over time. So none of these are like the big Barcelona supercomputer thing. But I like them because it shows the direction of HPC, that we don't run out of science or innovation or industry. So HPC keeps reinventing itself, and I am going to spend too long on this chart because I have some things I want to say. HPC in of itself keeps going because we don't run out of science, right? And as long as there's more science, there's more engineering, and there's more products, and there's more innovation. We have cloud, big data and analytics. There were the years where supercomputing was just a cloud show. Everybody talked about cloud. Then there were the years where supercomputing was a big data show, and all anyone talked about was big data. Now we're in the AI phase, and we're here at the HPC and AI Advisory Council because everyone's got to talk about AI. And AI is a real thing, and everyone asks us, hey, do you cover AI? And I want to just jump out and say yes, but it has to be a qualified yes, and here's the reason. Because as soon as I say yes, the next thing you're going to say is, what's the size of the market, right? And the second thing you'll say is, who are the leaders, by which you mean market share? Well, in order to do that, you have to really know what it is you're going to count, right? Like if I say it's $80 billion, well, how many AIs is that, and how much does each one cost? Right? At some point, it's got to be bracketed because a self-driving car, just to pick an example, isn't part of the AI market. It's part of the market for cars. It's already counted in the car market because people mostly aren't going to buy an extra car just to get one that's self-driving. You'll have a fixed number of cars that might or might not be self-driving, and I don't want to double count things in the market. Now, to really make my point, I'm going to go back one step to big data and analytics, which I promise you, for those of you who can't remember like 5-6 years ago, there was just as much zeal and enthusiasm around big data as there is now around AI. That executive order that just went out this week from the Trump administration about ensuring American leadership in AI, it's kind of a cool thing. I get it, develop the workforce. Does anyone remember that there was a similar executive order under the Obama administration to ensure American leadership in big data? Right? There was. Go back and look. There was a similar one. Big data was that big a thing. And we measured it. It's part of our methodology. But the question is, where were people spending money? If we set up a separate market and said big data is this however many billion-dollar market growing at umpty-ump%, that would be very popular. If you want to make a buck quick in market research, follow these 3 simple steps. Ready? 1, describe a market that everyone's excited about that's huge and really fast growing. 2, tell everyone that in order to address that whole market, all you have to do is one simple thing. And 3, that one simple thing should be what they already thought it was. Right?
So big data is going to be a $200 billion opportunity, doubling every year for 20 years. And if you do Hadoop, you get the whole thing. If I put out that market research report in 2013, everybody buys it. Everybody buys it, no matter how much it costs. The problem is, it's not really good advice. Because if we set up a market that says, here's the size of the big data and analytics market, high performance data and analytics, whatever we want to call it, and call it a distinct market with its own budget and independent spending, that would lead our clients to do things like come out with big data appliances or whole business units around big data, which a lot of HPC companies did, almost all of which totally failed within a couple of years. The better advice was, yeah, analytics is a very big deal, but mostly it's storage people already have, data they already have, people they already have, systems they already have. They might download some software, but most of that's free. And the big thing that's changing is they're integrating more flash to up their I/O. That was a really unpopular report to write. Okay? No one wanted to hear it, but it was pretty true. Now carry that forward into AI, we've got a similar sort of problem. Everyone's excited about AI, and people are doing AI. And we want to measure that AI and describe that accurately in terms of what people are buying, where's the money going, and that's the methodology that we're trying to bring to this market. Now, part of that's related to the hyperscale market. I always start with HPC, but hyperscale is out there too. This is where we track the Googles and the Facebooks and all that of the world. This is important because when people talk about who leads in AI, I don't think of countries like the United States and China and Russia. I think of companies like Google and Facebook and Amazon and Apple and Baidu and Alibaba. It's those companies that mostly are leading in AI. The hyperscale market grew 25% year over year. These are all, you're catching me a bad time of year because we haven't finished the 2018 numbers yet. It takes at least this long for people to close their books and another couple months for us to do the forecast. So these are all 2017 numbers. Come to Lugano in April and maybe I'll have an update on 2018 numbers. There were 9 of those companies that are tier 1 spending over $1 billion with $1 billion a year on IT in 2017. There might be 10 this year. I will tell you one of them might this past year have cracked the $10 billion mark on how much they spent on IT in a single year. To put that in perspective, a large supercomputer typically costs on the order of hundreds of millions of dollars. You get one hyperscale company, that can be 10 times that or more. It's going to keep consolidating more than it's going to keep expanding at this point. So AI, deep learning, machine learning, we can count in 2017 roughly $4.5 billion of dedicated spending on AI. What I mean by that is I can draw a circle around the servers doing it and say these systems are predominantly or primarily dedicated to AI or machine learning. 90+% of that, roughly 95, comes from the hyperscale market, where one of those big companies I just talked about will have dedicated infrastructure for AI. Among the rest, HPC users, yeah, they're doing machine learning and AI, but mostly not on dedicated hardware. It's more like what happened with big data. I changed my configuration. With big data, I put in more flash and I mixed in the analytics with everything else. With AI, I'm putting in more GPUs, right? And then I'm mixing it in with everybody else, mostly. And then there's some budgetary effect. Maybe my budget goes up a bit if I'm lucky, but I've got to request that in stream. So here's a look at machine learning in HPC sites. More than half of HPC sites already say they're doing some kind of machine learning. But most of the time, it's within the context of the systems and the budgets they already have, most of the time. The big exception to that is in finance right now. Finance is the vertical market that's gone the furthest in terms of actual systems on the ground doing machine learning. And I'll come back to that in a second. So here's the HPC market. It's a little smaller than the hyperscale market right now, but much less concentrated into that top tier. It's $35.4 billion in 2017. That looks like a pretty flat market overall, but that belied a lot of interesting dynamics underneath. Normally, these segments all track pretty well together, right? And 2016 versus 2017, they really shuffled. The reason servers had more of a bump relative to everything else is that dynamic I just talked about. More GPUs, more accelerators went in, so it was a more compute-heavy usage of the budget. If we went back to big data, storage was the thing that got the bump, and it was because of flash. I bought the same number of bytes, but more of it was flash, more dollars per byte, and storage got a bump. Right now, what we're getting is servers got a bump, and mostly because of that GPU factor. Cloud is the highest growth, but it's coming from the smallest base. And that will keep growing in the double digits, and has now crossed $1 billion for the first time. That's in 2017. It'll be up on that for 2018. So the product and services forecast looks like this. Now that looks kind of linear. I have two things to say about that. One is, as my partner, Chris Willard, our chief research officer, likes to say, when you do a forecast, it has to be bound in some sense by what's realistic, whereas reality has no such restrictions. Reality can go do whatever it wants, and it's hard to predict things like floods and new wars and things that really can skew a forecast. But the other thing is, all of the different segments within this are forecasted independently. We forecast all of the product segments, all of the classes from entry level up to supercomputer, all of the vertical markets, all the geographies, all have independent forecasts. And this is the aggregate you see of those. The green portion, second from the top, the cloud, you can see that big growth in that moving forward. The budget outlooks have all been going up, particularly in the government sector after years of flatness. The budgets are finally starting to loosen up there. The server classes we do have data on. I put that up here only to say that the growth has been concentrated recently toward the high end of the market. That's been growing faster than the lower part of the market, but they're all growing. Server shares, we obviously also count. HPE and Dell are in the number 1 and 2 spots and pretty close to each other, followed by a tier of a lot of people. Now, Cray had that bad year in 2017. That doesn't concern me too much. Cray's business has always been very chunky according to what deals it does or doesn't get, and I didn't see that as being long-term alarming. IBM concerned me a little bit more, just because, here they are at IBM Think this week, and all they talk about is AI all the time. AI is great, but geez, you got the 2 largest supercomputers in the world, and you're afraid to call them supercomputers. IBM is so good at talking about the future, and they've been poor at selling what they have today. And that does concern me, and I hope they can turn that around. This is the difference between, all right, so when we do market share, this is actual revenue numbers that we put out, and I took the numbers off. We have them. You can buy them. We also, one of the main inputs to that is survey responses, right? So we survey end users and ask them what they have, and that's usually pretty similar to how we do the market model and forecast. So that's it's probably the major input that we have, that together with the budget and what people say they spent. AWS, by the way, is the top named cloud vendor, and they're also the top cloud revenue in our model. Storage shares, we also do. Dell EMC is the largest, just because EMC has so many different storage products here. People talk about HPC storage, and there's a tendency to want to run immediately to things like DDN and Panasys because they're dedicated to the high-performance storage space. But the fact of the matter is, especially in those commercial markets that make up more than half the space, there's a lot of NetApp and EMC out there. Then I get my partition and I'm running HPC applications on it. I'm paying for it out of my budget. So it's not it's storage for HPC applications is what we mean here. It gets paid for out of that budget. And there's a lot of it. Also in EMC, consider all the extreme I/O they had with Flash gave them a ton of revenue there, a lot of which is high performance affiliated. Now the fact that NetApp has a new partnership with Lenovo and Dell is together with EMC kind of brings up some questions about some of the other partnerships. And in particular, what's HPE going to do with its storage strategy? Because that's where they're number one in servers, but they're number three in storage, and the people ahead of them are naturally aligned to other places. Now, when we go to the survey responses, that's where DDN pops up really high on storage. But here's where we have to be smart as analysts about the difference between survey responses and market shares, and that's because when people have DDN or Panasys storage, they automatically think of it as HPC storage. But when they have EMC or NetApp storage, that's not necessarily true. There's actually a market research term for that called sample bias, and you have to be aware of when you're running into it. So that's why the model can look different than the survey. All right, vertical markets I'm going to do real quick, and I'm going to hit page down again just to put those arrows on it. I'm not going to read through all of these, but we have the verticalization of the market, and you can see that the commercial markets are more than half by revenue, and they're still driving the major part of the growth rates. I highlight financial services because of what I said before about AI. AI is a big deal in financial services right now. The major workloads there have been risk management and trading. A lesser thought of workload is in pricing, and that's where a lot of the AI is coming into play. Has anyone heard a presentation on personalized medicine at any point? Probably, right? Really marketable. Anyone heard a presentation on personalized interest rates? You have not. You're going to have a personalized interest rate before you have personalized medicine. I'm here to promise you. Why? There's a lot of money in it. The hard thing is to get past the regulatory environments because you can't have predatory lending where you give white people a better interest rate than Latinos or men a better interest rate than women. So you also have the linear algebra problem of how do you go to personalized interest rates without discriminating against any group. But okay, so you made the math problem harder. There's still plenty of money in it, and I think that's where AI is going to drive that. Oh, the other arrow that was on that chemical here, I mean chemical engineering like plastics and polymers. Now, there's certainly other chemical engineering in biosciences. There's biochemistry here, and in energy, there are all the petrochemicals. But chemical engineering, that segment up there, Dow, DuPont, BASF, 3M, Solvay, companies like that do chemical engineering. I highlighted because that's our highest growth rate commercial segment in the market right now. And in fact, BASF got that kicked off with their Curiosity supercomputer, and I think that's going to spur more investment there. We have lots of end user data in these site census and budget map surveys. The interesting thing I wanted to highlight on this one, we could go to just depths of detail here, but we really want to see what's going on with OmniPath. They kind of got a bump among the high performance interconnects, but a lot of that came from not out of InfiniBand, but out of the Ethernet, out of the high performance Ethernet. And it also didn't keep growing year over year in the last survey. So we want to keep watching this and see what happens with OmniPath in terms of that long-term direction. InfiniBand has really been, in particular from Mellanox, who's the de facto InfiniBand, has been dominant in this space, not only as a system interconnect, but they've also been the big grower in terms of storage interconnects. That's where a lot of the growth has come from for InfiniBand recently. We track applications. These are top generally available applications. Again, these are survey responses. If you want to really screw up talking to people about market share, start talking about software, because market share, usually people want to talk about revenue, right? Well, now anything that's free has no share, regardless of how many people use it. So you could go by installations, but then anything that comes pre-installed gets 100% share even if nobody turns it on. So it kind of leaves you a bit nowhere, right? We use survey responses as just asking, tell us what your top applications are, as a proxy for usage, which is really what most people are asking about when they mean market share in this context. It is a highly diversified area. These are the applications that get at least 2% of responses. After that, they start thinning out. And this already takes out all the ones that are in-house. Because an in-house application by default has an N value of 1. It's the unfused crumb in the brownie pan that's not attached to any other brownie. Oh well, doesn't mean it's not important to anybody. It's very important to that customer, right? If you add those back in, it's a big chunk of things that have an end value of 1 and everything else compresses down. A look ahead to 2019. These are just a couple of things that I wanted to put onto a chart. I could talk about this ad infinitum, but early indicators suggest strong growth. When I say early indicators, we're looking both on the supply side and on the demand side. Supply side, we look at people's quarterly earnings, annual earnings, we look at those reports, and then we have to generally back out to what the HPC business does. Another hard thing about being an analyst in this space is we can't just add up numbers right off of an annual report and sell them back for $60,000 a year, because generally HPC isn't a separate business unit for most of these companies. We have to figure out what proportion of their business comes from HPC. And we do that. We do a good job of it. And we're looking for strong growth here. So that's the supply side. The demand side, budget indicators. We ask people what they think their budget is doing year over year. So we get those also, and that's a key element in our forecast. AI augmented HPC is a big thing I want to discuss here for just a second, because I don't think AI is displacing HPC. I think it's going to, well, augment or partner with HPC in a lot of areas. And it's fun to start thinking about what areas those might be. And now there's already influence in things like precision. We've had great discussions about when you can do 32-bit, 16-bit, or mixed precision as part of your calculations. Do you really need double precision all the time? That's a really valuable discussion, because I think a lot of time we're doing double precision calculation on a model that's not that good, right? So, you know, would you be better off reducing the precision and putting more work into the model? Okay, so that's fine, but that's separate from that. Where can we marry AI together with HPC? One of my favorite examples, we've been talking about engineer in the loop or person in the loop simulations in this space for 25 years. But a lot of it never took off because the latency human to computer just was never right for having a human steering a multi-physics application in a way that you get a lot of that done. Well, how about AI in the loop though? If we can teach AI to play Go or poker, we can give it the rules for optimize the airplane wing as a game, right? Here are the rules you're playing with, and here's the current model, and teach it to play perturb the model and look for a new design. And then it's not to take the engineer out of it. Now you're going to do that for target reduction like we do in other industries. Now the engineer can review suggested design changes that come from the AI. I'll give you another one that's related to storage tiers, which are on here. Storage tiers are proliferating like crazy, right? And we just had the presentation from Intel on the persistent memory, which is great. But when we used to talk about tiered storage, we had 2 tiers. You had disk, you had tape. Those were your tiers. Now tiered storage, by the time you have persistent memory and a burst buffer and 2 different speeds of disk and a nearline archive and tape, and you're storing some data in the cloud, you could have 5, 6, 7 tiers legitimately. And I think that what it means to me as an analyst, if I try to crystal ball this, rolling that forward for commercial markets in particular in HPC, I don't think we're going to talk about high performance storage so much in terms of a parallel file system and having really high bandwidth to one tier. I think performance in the medium term here is more about how do I have the right data on the right tier at the right time. I can't necessarily afford to put all the data into memory or persistent memory all the time. I'm still going to be living with disk and archive and other things. But what I'd like to do is heat that data up before I ask for it, right? Well, now we're talking about AI again, right? If I could have maybe an object, and no one ever talks about object with high performance, okay, because of the overhead. But what if you had an object-based environment where an AI was in charge and an AI was monitoring your usage pattern, including what you're clicking on, what you're typing at the command line, and get predictive about, I'm going to promote this data because I think you're about to ask for it. And then by the time I ask for it, there it is on a hot tier. that becomes high performance storage. And if you think that sounds implausible, the hyperscale guys do this now, right? Because if I go to Facebook and start scrolling back my friend's wall because I'm looking for a picture from a Halloween party, 8 years ago, and I'm going like this on my phone, and I get to the little wheel that goes diggy, 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 and I gotta wait 6 freaking seconds for you to load up. I'm not gonna wait 6 seconds. Are you kidding me? Consumers are fickle that way, or buffering a movie, right? You're trying to pick a movie. Do you think it's waiting for you to actually select it before it starts to pre-buffer the ones that you might pick, right? That becomes high performance because I don't want to wait 6 seconds. I hate that. Consumers hate that. So the hyperscale companies are very sensitive to that, and how can they heat up data that's about to be requested? The processor wars are still going crazy. I am very concerned about the software ecosystems here. Yeah, AMD is back. They've got great looking products on CPU and GPU, but they're behind both NVIDIA and Intel on the software ecosystem, and that's where that's got to get caught up. ARM, same thing. We only just put our first petascale ARM system on the top 500 list, and we're supposed to be getting to exascale with ARM in a couple of years. That's 1,000 times jump. I want to know about the software ecosystem around that. Now, there are answers. Companies like Cray and Atos and Fujitsu have their custom environments that they say are going to scale, but it's like, how high do you have to build a building to prove that you can build it 100 stories high? Well, every story up gives you some credibility, but you haven't proven it till you get there. The battle to possess data is not going anywhere. That's the fight in hyperscale in particular. I don't care about ownership of data, possession of data. I want your data in my cloud because then I win. And that's true of HPC all the way down to these phones. I never wanted any of my data in iCloud. I didn't. I backed it all up locally. I wanted it on my laptop and my home server. They eventually forced me into the cloud, and I hated that. I didn't want it. But it's eventually unavoidable. And I think there are going to be more acquisition targets in this space. I tried to catch up time as best I could. Thank you. Do you want me to take questions, or are we dead? I started 10 minutes late and ended 3 minutes late. So I'm happy to take questions. That wasn't meant to be pressure. Yes?
You mentioned about AMD having to catch up with software.
Uh-huh.
They kind of inherit that activity that they do with ISO. So what do you mean by they have to catch up with software?
What do I mean by AMD has to catch up in software? You're right that it's x86. Most of it has to be done on the GPU side with the conversion of getting stuff from CUDA onto their GPUs. Now, in the near term, I think we will see people who will try AMD CPUs with NVIDIA GPUs. There's no reason that won't work, although AMD doesn't want to market that because they've got their own GPUs, thank you very much. But even though it's all x86, I think there's still some porting questions. Yes?
So you had the growth in the cloud sector, now $1 billion. So what's HPCwire is going into the cloud? What segments? How do you see that evolving? And you talked about more.
Right. What segments are most attractive to cloud? Public sector, academic, government both use cloud for HPC more than private sector does. As much as people would like to tell you all the great commercial examples, and they're true, but cloud usage tends to be for a portion of an overall workload. And in particular, there's a lot of cloud bursting or just going over capacity. In some segments, it's a question, like for example, in finance, they will make use of cloud, but not for some of their most critical HPC stuff. They'll find out what's less essential and break that off to cloud to keep their higher performance environment internally. Manufacturing has been kind of in second behind the public sector. The one that surprised me is oil and gas. I would have thought they would have been the last with their backs to the wall when the revolution came. And yet we've seen a lot of cloud trial in oil and gas, trying to go cloud native with the massive data sets first and seeing can they live that way and do a lot of their primary data reduction there rather than start on-premise and migrate to cloud selectively. So those have been trials. I think we're a long way from seeing a big shift there, but I've been surprised about how much enthusiasm there was in that market to test it last year. Yes?
So there's a lot of excitement with cloud. What really talks about is the cost of cloud on serious large-scale runs. A lot of electricity you're paying on that, right?
Right.
It's not free.
Right.
So if you look at, overall long-term usage, right, of a conventional cloud, it's not optimized to an application, right? Deeply optimized. Is there any trend the opposite direction, rather than highly virtualized to, really abstracted cloud offering versus really deeply embedded on the other side, because you can have a massive, performance and power savings if you go the other.
Is there any trend moving back toward on-premise, away from cloud? Yes, absolutely there is.
Because of the cost of cloud.
Yeah.
Everybody got drunk on cloud, and all of a sudden.
Right. All right. So cloud is not, everyone's going to gasp. Cloud is not cheaper. Okay? It's not. A great metaphor is, gosh, Chris said this years ago. He said the basic selling metaphor is if I came to you and said, if instead of your car, cheaper than your car, I could give you on-demand chauffeured service wherever you wanted to go for less cost than your car, are you interested? Sounds pretty good. Sure, I'm interested. Great. Here's the bus schedule. And for when you really need higher performance, the number for the taxi company, right? And I promise you that combination, taking the bus whenever you don't really need to be there so fast, and then taxi, I hate the bus, right? I want the taxi, but then the taxi becomes more expensive, right? It's only cheaper if I can really go with that cheaper option. Now, there are people who live in metropolitan areas where the cost of car ownership is higher and the availability of public transportation is more robust, where hey, I live in Tokyo or Manhattan, I don't need a car. But that doesn't make them the market leaders who are paving the way for the rest of us to get rid of our cars. I take trains sometimes. That doesn't mean I'm getting rid of my car. And it's a pretty good metaphor, actually, for where we are with cloud and HPC. If I dedicated to myself to using all cloud all the time, people who spend a couple $1 million a year on an HPC infrastructure and run it at 95% all the time, to turn that off and move it all to cloud does not get cheaper, I promise. It's much more expensive to do it that way. And that's a big reason why on-premise still pervades as the predominant mechanism for HPC throughout the forecast. See, I got excited. Why is Apple forcing me to put my stuff in iCloud? For possession of data, of course, right? Because then if later on I decide I want a Samsung phone, well, all my stuff's in iCloud, so that becomes harder. Now, that's annoying on the consumer side, and this kind of transcends HPC, but I predict the same thing is going to happen in enterprise, right? If you're in an enterprise and you're pushing all your stuff out to a public cloud provider. Remember the 90s when people would talk about vendor lock-in like that was a bad thing, right? I can't buy all HP or all IBM. I'd be locked in. And then you get the same companies now who are pouring petabytes of data into the cloud as fast as they can. That's vendor lock-in like you've never heard of. Are you kidding me? Oh, well, I've got a 3-year SLA. Awesome, a 3-year SLA. And then after that, they can charge you what? Infinity to get to your data, right? Without any limit. What are you going to do? Download it back? Are you kidding me? I mean, you're going to be a total hostage. And I actually had somebody say, well, yeah, I could send a truck full of tapes. Like, to where? To the cloud? Is that where you're going to send your truck? Because that's where your data is? Right? Like, that's a place. That's the fundamental understanding people don't really have. Now, yet, there are other things. So we all trust the internet every day, and that seems to keep working for us, and we don't feel like we're hostage to the internet. So maybe it all works out with cloud, but If I were in enterprise, I would at least keep a copy of all of my data somewhere, so that, even if it's in a bunker underground, so that if I want to change cloud providers, I can unearth my bunker and bring over my data and say, all right, I've got it. There's one more here.
Yeah, you had a bunch of charts that said HPC. Is that really defined by the workload, and does that have to be simulation, or can it also include machine learning?
Right. What defines HPC in this context? It is not the computer itself, because the same computer can run an HPC or a non-HPC workload. It really is workload driven. And yes, that can absolutely include machine learning. The question there is, what aspects of that workload are really parallel across multiple nodes and reliant on some aspect of performance or scalability in compute, in memory, in data, in networking. A lot of training really does fit the profile of a high performance application, and it drives HPC types of environments. We see it mixed in with other HPC workloads. In the context of hyperscale, we could try to dissect hyperscale and say, okay, these servers are really properly counted as HPC because they're doing machine learning. Because they're contained already in the hyperscale market, and we're trying not to confuse things, I don't really want to go and say, okay, 3% of Google's infrastructure is HPC. We've avoided doing that so far, but stay tuned. We might get forced to by our own methodology at some point.
So to count as HPC, you have to be a cluster across multiple nodes. It can't be DGX2.
Two nodes is our minimum. Right. The question was, does it have to be multi-node? If it's all on one node, then really that's a workstation to us. And we don't count PCs and workstations in our methodology. Now, DGX2, that really is multiple nodes in a box. Nevertheless, the DGX2, as much as they talk about it for HPC, that's a hyperscale platform more than an HPC platform. That 8:1 GPU to CPU ratio is out of bounds for the wide range of HPC applications. We rarely see more than 4:1 GPU, CPU. So that's really a machine learning platform, and is going to be delivered primarily as an HGX2 in hyperscale environments. Render farm is a great question. We used to count them as HPC, and that is an example of a rare application that didn't keep getting more complicated as fast as computers got more powerful. When I started in this industry, that would be done on like a big, powerful Silicon Graphics Onyx. It was the big HPC application, and then it went down to clusters of servers, clusters of workstations, clusters of PCs, grids of PCs, and it's really dropped out of the bottom of the HPC market, and we're not counting it anymore. We do count digital content creation and distribution, like streaming, in the hyperscale market. We do have media and entertainment still in the HPC market, but it's much smaller than it used to be. It's really just high-end visual effects that require HPC. Finding the next large prime number is another great example. When I started in this industry, that was a job for a cray. Now you download targets to your phone and leave it running overnight. It's not an HPC application anymore. And I'm glad you mentioned it. I'm going to spend 30 more seconds on this because, as a thought question for the audience, consider, will that same thing happen with AI? Does AI, in the long run, keep getting more complicated as fast as computing gets more powerful? Or in 20, 30 years' time, does it drift out of the bottom of the market and it's not really considered a high-performance workload? I don't have the answer to that question right now, but it is something we've thought about in our methodology. And we're running late here, but I'll keep answering as long as Sydney keeps letting me.
That's in the rendering work.
Yeah.
It's actually, in the last 5 years, it's shifted because they're starting to do more transport simulation. So it's back to HPC, the high-end rendering.
Congratulations, you're an analyst. Going once, going twice. Thank you very much, everybody.